So I'm going to open Notebook 5, and Notebook 5 is called Retrieving Information from the PDB Using the Web API. And we're going to be, there are a lot of PDB APIs here, but we're going to be looking at how we can search the PDB using Python and then get those search results into Python. So before I talk about that, I want to go back to the PDB. And we've already said something about that. So we've talked about the advanced search. So here in our search bar, we can type in search terms, entry IDs, sequences, etc. You can also click this button to do an advanced search. Right, so here's an advanced search query builder. And this is going to allow us to search different entries in the PDB for different information. So we can search the full text of a PDB entry. We can look for certain structure attributes. So there's a lot of different things that we can search for. You can search for sequence similarity. So if you have the sequence of a protein, you can put the sequence in here and get proteins that have a similar sequence. So there's a lot that you can do here with the search. So I'm going to do, what do I want to search for? So let's say I want to do something. I want to search maybe for oxygen storage. And I can get, say, a set of entries here that have that phrase somewhere. I think I actually wanted to put it in quotes. Yeah, I wanted to put oxygen storage in quotes. And then it's going to give me a list of protein structures that have that phrase somewhere in the entry. So this is really great, and I can see what all of these are here. You can see that there are 619 structures that it returned, and we can see this in our browser. And I'm going to show how we can retrieve this using Python instead of the browser. So we are going to use something in the protein data bank called the REST API. Right here, I'm just calling it a web API, which API stands for Application Programming Interface. So we'll explain sort of how this works and then how we can use Python to retrieve this information. So before I go into that, I want to say a little bit about downloading mmCIF files using BioPython. So this is just sort of retrieving information from Python. So if you want to download a particular mmCIF file, we can do that with BioPython. And this cell just demonstrates to you how to do that. So here, this is just the code. We import something called PDB list from BioPython. We create an instance of PDB list. Then we define the PDB ID that we want to download. So this is for hemoglobin, for HHB. And then you can use a function called retrieve PDB file and tell it to put the PDB file it gets in your data PDBs files folder in the format of mmCIF. And so this is just, this notebook just demonstrates several ways that you can use Python to get information from the internet. So if I'll just show what this, I'll just show what this code does. So if I look at my data folder, my PDB files, I've got one A1T and one MBN. If I want to get any PDB file, I just need to change, I can use this code and I just need to change my PDB ID. So I'm going to execute this to show you. I think I need to refresh the file list. It should be in my PDBs files folder. Where did it go? Oh, it's still executing. I don't know why it's taking so long. Is everyone's running okay?
Yes.
Okay. Did everyone else's finish? I'm gonna restart my kernel because it shouldn't take that long to download. Okay, let me try that again. Did other people's finish downloading?
Yep. Yes.
Okay, mine is hanging up and I'm not sure why, so I'm just going to skip that. But you can believe me that that should download the download it for you, and I'm not sure why that wasn't working for me. It seems like it worked for other people and it has never not worked for me before. Anyway, so that's just a demonstration of how you can use BioPython to download a structure from the PDB. So the PDB also has something called an API that you can use. And this is something called a REST API, which is something that's kind of commonly used on the internet to give you data in a way that you can access programmatically. So the way a REST API works is it's just like an address for a website, except that you fill in basically variables that gives information about what you want to retrieve. And there are lots of websites that use APIs, like even non-scientific ones, but most databases that you interact with have APIs like this. So for example, if you've ever used PubChem has an API that you can use. It's called PubRest, but the PDB has an API as well, and it has this format. So we start with a URL that looks like this, and then we add in the type of resource that we want to retrieve. So this could be like an entry from the PDB, and then we give an identifier for that entry. So for example, if we want to get the entry for 4HHB, we take this URL and then we fill in the word entry and then the PDB ID. So you can actually click on this if you want, and that's going to open a new window for you. And so this is just like you typed a URL into your search bar, like google.com, except we've typed in data.rcsb.org and then rest v1. And then we said we wanted the entry for 4HHB. And then it's going to give us a bunch of text that tells us about that entry. So if we wanted to see an entry for something else, like let's say we wanted to do 1A1T, which is the zinc finger that we were looking at, we can change that PDB ID. And then it's going to tell us the information for that entry. So this is just something, this kind of concept where we have a URL that we're manipulating to get different information. That's something that's called a REST API, and this is actually really commonly used across the web. And it's used usually to make websites, but it can also be, we can also use it in Python, a REST API, and get some information to analyze. So that's the entry for 4HHB. You'll see that by altering this a little bit, you can also get like annotations from PubMed for different entries. And really there's a lot, this is called the PDB Data API, and there's a lot that you can do with it if you read the documentation. So it would just be basically changing that URL that you're looking at to get different information about the entry. Okay, so what does this have to do with Python? We're going to use a library in Python to get information from that web URL, and then we can analyze it. We can analyze it using like Python functions. So we're going to use a library in Python called requests. And request lets you pull in information from the web, like any URL, into your Python environment. So we'll import requests. And then we're going to use requests to get information from a URL. And the method that we're going to get is called requests.get. So we'll create a variable called data and set that equal to requests.get. And then we open, close the parentheses, and then we'll put our quotes. And then in those quotes, we're going to put the URL that we would like to get information from. So I want to get the information from this website into Python. So I'm going to copy it. Just copy this. Well, Control-C is really the best way to do it. And I'm going to put that in quotes. And what request is going to do is it's going to go to this URL that we gave it. It's going to get the information that's there, and it's going to make it available for us in Python. So I'll just type that in, and then I'm going to, oops, I forgot to execute my cell where I imported request. So make sure you run that. And then we'll do request.get. If it gets something, we won't see any output here. But usually what you want to do is you'll want to check the status code. So just to make sure that everything is okay. And this is something that is common on the web. Every time you go to a website, it sends a status code along with what you see. And if everything works, the status code is usually 200. Another status code that you might be familiar with is 404. So if you've ever seen a page that says 404 not found, that's a status code that gets sent when something can't be found. So I'll just demonstrate to you here. If I gave like a nonsense PDB ID, like it would still execute, but here I would see a 404 status code instead of a 200. So it's a good idea to check your status code to make sure that you've retrieved, actually retrieved something. So I'm going to delete that and run this again. I should see my 200 status code. And then if we want to see the actual data that was retrieved, we're going to create another variable. We have to use a function called JSON on this data that we retrieved. And that's going to give us all of the data that we saw here. It's going to give us that data as a Python dictionary. So this is another place where dictionaries are going to be important. So I'm going to create a variable called info underscore for HHB. I'm going to set that equal to data.json. And then I will maybe print the type of this just to show you. So we have now a variable called for HHB. We've set it equal to data.json. And what we have now is a dictionary. So if you are with me, can you use your green check mark, please? All right, let's look at what is actually in this dictionary. So I'll do info for HHB, and I'm just going to print the keys. So here you'll notice that there are a lot of things that are similar, kind of similar to what we saw before when we were like using BioPython with the mmCIF to dict. It's not exactly the same, but this has information about that entry. So here you'll see that we've got, say, information about the cell under a cell keyword. We can see the citation under the citation keyword. We maybe have like the symmetry information, the structure keywords. So we can see different things about the entry here. So note that this doesn't have any of the structural information that's like in the file itself, but it does have like this data API does have information about the entry. So I could do something like for HHB, I could look at what the cell information is. It's going to tell me the length of the cell and then the angles associated with it. I can also look at information about the experimental method using this keyword. That's going to tell me that this structure was determined using X-ray diffraction. I can see one other one that's interesting is the structure keywords. So I might do info for HHB, struct keywords. And then it's going to tell me that the keywords for this one are oxygen transport. So you could just really use any of these to kind of see information about that PDB entry. If you read, so if you go to the PDB website and you Google like API, like PDB API, you can find some documentation for it. One thing that I thought was interesting that you can do is that you can, from the API, you can get information about the interfaces in the protein. So here, I've partially filled this in. If you want to get information about interfaces, here you have interface instead of entry. Then you can fill in the PDB ID. So we can fill in for HHB. And then we can fill in the assembly ID, which there can be multiple assemblies in a protein entry, and then the interface ID. So this is basically where like different protein chains are interfacing with one another. So let's say I wanted in for HHB to get assembly ID 1 and the interface 1, like I can retrieve that information. And then it's going to tell me about the interface area, for example, or the number of interface residues. And we can kind of vary this if we want to see a different interface in the same structure. So there, if you read the documentation for the API, there's a lot of different information that you can retrieve. This is just one that I thought was interesting. Okay. So that was the PDB data API, and that's useful if we know the ID for the structure that we'd like to retrieve information about. But a lot of times what you'd like to do is you'd like to search the PDB for a particular type of information or a particular type of protein, or like a particular, like maybe protein structure or something like that. And this is going to tie back to what I showed about the advanced search that you can do on the website. So anything that you can do in the advanced search on the website, you can also do if you figure out how to write your URL correctly. And for this, we're going to use, instead of the PDB data API, we're going to use the PDB search API. So here, the URL is slightly different. But here, what we're doing now is we're going to, in our URL, we're going to put a search request. So it looks something like this, search.rcsb.org, and then query, and then a question mark, and then we'll say JSON equals search request. And what that search request is going to be is essentially a Python dictionary that defines what you're searching for. And I've included kind of the general format that you use for that. But where I got that from is from this. I have a link here to the RCSB PDB search API. So if you want to know how I knew what to do, you can go to that documentation and read about how to format the query. So we're using a Python package here called JSON. Then we're creating a Python dictionary called myQuery. And here we're saying that we want to do a search of the full text. And you'll remember, I'll bring up the search that I did here. It's essentially, I had typed oxygen storage here. You'll see it's full text. So it's the same thing that we're seeing in the website interface. But here we're searching the full text for oxygen storage, and I've put oxygen storage in quotes here, just the same way that we did when we searched on the website. And then we're going to put this into something that we can actually use with the API. So I'll execute that. It's going to look like nothing happened. but we're going to do another retrieval using Python. So we'll do requests.get and then open and close parentheses. And then in quotes, you're going to take this URL and put it in quotes. And we're actually going to use a formatted string here. So this is an example of another place where formatted strings are important. And I want you to put in the variable name for your dictionary that is your query. So we're going to put in my query. So here we are going to send this query to the API endpoint. Okay, so I executed that. It looks like nothing happened, but we have this number here. And then we can do, we want to convert it like we were doing before. So we can do results equals data.json. So this is an important step to convert our results to a dictionary. And I will just put results here so we can see what those results were. Okay, so that is how we would do that. So we used request.get with our search query. We converted the data that we retrieved to a dictionary. And then this is what we retrieved from that API. So you'll see here that it tells us that we're getting entries. It tells us that our query returned a total of 619 results, which you may not remember, but if I go here, it's actually the same thing. I think that was oxygen storage. So here you'll see it's 16 and 619 structures. So it's the same thing that we would get. And here it tells us we have a results set, and it tells us the PDB IDs for all of our results. And if you go back and compare, it's the same thing that you saw in the web page. So one question you might have is it says that there were a total of 619 results. Why do I only see 10 here? And that's because this API is only going to return 10 results to you unless you tell it that you want more of them. So here I've pulled out, let's say what we could do is we can take this dictionary called results. We see there's a keyword called results set. And then if I wanted to know the ID of the first one, I would index 0 into it and then get, this is another dictionary. So this is kind of a complicated data structure. And you can get the ID. So actually, let's pause here. If this works for you, if you're able to see this, can you use your green check mark? And if it didn't work, I'm actually going to clear all the reactions. And if it didn't work, please use your red X.